Okay, welcome to this recording. I'm going to be solving problems from the problem sheet that I had given you. So, this is the problem sheet on diodes, right? So, let's start with problem 1 and let's look at problem 1A. Okay, in this, we have a circuit where you have a resistance, and this resistance is connected to a diode, and the diode is connected to the ground. So the input here is plus 5 volts. The resistance is given as 2.5 kilo ohm, and we are taking V out from here. Right, and what the question asks is for us to find out. Let me take a look. It just says solve the circuits, and by solving the circuits, basically we mean find out the V out, maybe the currents in the resistor and the diode. Okay, so how do we do this problem? So as we said in the class, we will have to imagine, we'll have to assume, diode has two modes, isn't it? A diode can either be forward biased or it could be reverse biased. And what we are saying is, okay, let's make an assumption in this case. I mean, if you can't really see, let's assume that you don't know what state the diode is in, and you say, okay, I don't know. So let's make an assumption. So let's say, assume that the diode is in forward bias. Assume. Now, now, if the diode is in forward bias, what are the conditions? Now, there are two things that has to happen, right, in the forward bias. One is that the voltage across the diode has to be positive. So this side, the V out side, has to be more positive than the ground side. So that's one condition for the forward bias. Another condition is that the current that is flowing into the diode should be flowing from top to bottom, and that current should be positive, right? So there are these two conditions, and what we want to do is, I don't know, let's write it, okay? So let's say uh, Vd, which is equal to V out, should be greater than 0, and then let's say id should also be greater than 0, and I'm going to write id like this. Okay, and let's write vd like this. Both of them have to be true for the diode to be in forward bias. And what we will do is we'll assume the diode to be in forward bias, and at a later stage we'll check whether these two conditions are being met or not. Make sense? Okay, so let's assume that the diode is in forward bias. If it is in forward bias, then what we can do is we can replace the diode. Let's assume an ideal diode model. We can replace this diode with a short circuit, right? So instead of the diode, we can just put a short circuit. Now let's calculate what our voltages are. So what we get is we have V out equal to 0 volts, right? Why is it 0 volts? Because V out is connected directly to the ground. The voltage of the ground is 0, so V out is 0. All right. What is the current then? Let's say, what's the current ID? Now, what you notice is the current that flows, the current ID is the same current that flows through this resistance as well. Because no current is going like this, right? Because this is an open path. No current can flow like this. So whatever current is flowing through the diode also flows through the resistance. So what is the current flowing through the resistance? It is given by 5, which is the voltage on this side, minus 0 divided by 2.5 kilo ohms. So that gives us 2 milliamperes, right? And now you can check the conditions. You can see that yes, ID is greater than 0, and yes, V out is greater than 0. Well, we should modify this condition, right? It should be greater than or equal to 0. Because when the diode is on and we look at the ideal diode model, the VD is equal to 0. Okay, and that's the solution for this problem. Now let's take part B as well. I'm going to do part B as well just because to help you see how we solve these problems. Okay, let's do part B. So here's 1B, and in this case again we have a resistor. The circuit actually is exactly the same, but the diode, other than the fact that the diode is connected opposite, right? So this is V out, this is plus 5 volts, this is 2.5 kilo ohms, and now let's call this VD, and let's call, well, if the current has to flow, the current has to flow like this, right? ID. Does that make sense? Because the or just, okay, let's say this. So in the diode, the current can only flow in this direction, right? From bottom to top, from the P to the N side. It cannot flow the opposite direction. So I'm putting my current in this direction. Okay. You could also do this. What you could say is, well, I'll let my current be here, and then for forward bias in a diode, then what do we want? We'll need to have ID less than 0, because we need to have current from the P side to the N side, so in this direction. But since we are measuring current in the opposite direction, we'll have our ID less than 0. Okay. And also for forward bias, we will need, what will our VD be? Our VD will also have to be less than equal to 0. Now why is VD supposed to be less than 0? Look at how we are measuring the diode voltage in this case. uh, instead of measuring, instead of having the P side as positive and the N side as negative, we wrote plus minus here, right? The opposite way. And so VD is less than 0. We'll have to put the condition. If all this confuses you, I think one of the ways to do it would be to say, okay, I don't want all this. This is way too confusing for me. So in that case, what you can do is you can say, let's write it this way. And let's say this is the P side and this is the N side. So then you say plus minus, that's my VD, and my ID is in the correct direction from P to N, and then my conditions change. My ID should be greater than 0 and my VD should be greater than equal to 0. That's the conditions for forward bias, right? And what we'll do is we'll assume the diode to be in forward bias and see whether these conditions are met. All right, so let's do that. So if you have your circuit in forward bias, how does the circuit look? You can replace your diode here with a short circuit. Let's do that. And now you can calculate the voltage and the current. And now the voltage and the current we have already calculated, right? In the previous slide, it's going to be V out is going to be equal to 0. Okay, and then we have ID equal to what would this be? It's 2 milliamperes, but it's minus 2 milliamperes, because remember the current is flowing 5 minus 0, it's flowing downwards, right? But here in this circuit we are measuring the ID upwards, so we say minus 2 milliamperes. V out is 0 and V out is same as V out is equal to minus VD, which means VD is equal to 0 volts again, because V out is 0, so minus 0 is 0. So we'll leave it there. Now you may say, I hope you see why V out is minus VD, because think about how we are measuring V out. If you're measuring V out, this is plus, right? The term, and this is the ground is your reference point. But when you are measuring VD, we are using this point as our reference, the opposite. So VD is opposite to V out, so that's why minus V. And now you can look at these conditions and say, well, this condition definitely does not meet the conditions for forward bias. So the diode is not in forward bias. Okay. So if it is not in forward bias, then you'll have to say the diode is in reverse bias. If it is in reverse bias, what do you replace the diode with? you replace it with an open circuit. So you replace it with an open circuit, and now you calculate your V out. Now, how would you calculate V out? Now, what can you say about ID in this case? The current that is flowing through this resistance and through the diode. Through the diode, there is no current flowing, right? It's reverse biased, it's open circuited, so no current flows. But if a current does not flow through the diode, and if a current does not flow from to the output, then no current can flow through the resistance as well. And therefore, what will V out be? V out equal to 5 volts, right? And ID, of course, is equal to 0. Now check. Does that mean that your diode is in reverse bias? Yes, right? V out is 5 volts, so the N side is higher in potential than the P side, so the diode is in reverse bias, and ID is equal to 0. So that meets the reverse bias condition. So that's our solution to problem B. I'll leave you to do problem C and D yourself, and you can take a look at the solutions if you need to. Okay.